Welcome everyone. This is the first seminar of 2022, the Data Learning seminars. And today, to start the year, we have Luis Martí from Inria Chile, who will be speaking about OceanIA. So Luis, I'll leave the audience with you.
Awesome. Thank you very much. Well, thank you for the invitation. And we have been planning this for a long time now, so I'm really thrilled to talk to you about some of the work we are doing here in Inria Chile, in particular regarding to a project that for us is a very big one and also very important, that is called OceanIA, and it's in French, sorry, it's like Ocean AI. It's how we apply artificial intelligence to try to understand the ocean and the particular relation of the ocean to climate change. And the overall project is led by Nayat Sanchez-P, which she is also the director of INRIA, the INRIA Center in Chile, and by me, that I am the scientific director of the INRIA Center in Chile. So I will start briefly because not everybody knows the center, and I'm sorry, but I also have this mission of getting people to know not only our scientific work, but our work in general. So INRIA has more than 50 years now. Is the French Institute for Research on Digital Science or Computational Sciences. The original name had to do with informatics and automatic, but right now INRIA is the name. So it's no longer an acronym. And we work in all areas of computer science, essentially. So it's like, it's funny because sometimes I'm talking to somebody and this person might ask me, does INRIA works? And I don't need them to finish the question, which probably we do, because in INRIA we are like 4,000 researchers in different areas of computer science. And well, you know, also not only computer science, but also applied mathematics and other related fields. Just to give you an idea, my former team of INRIA, we had social scientists and all of that interested in AI and social science and all of that. So, but the core, the spirit of the center is to work around computer science. No, there are 9 centers. Actually, this slide should be updated because the little orange center in Lyon, now that was like an antenna, as we call it, a smaller center. Now it's a fully fledged center. So we are distributed in France in different places. And INRIA in Chile is the only center of INRIA abroad France. And we have been here for some time, but I will tell you a little bit about it and answering your question. Although INRIA works in, let's say, different areas of computer science, we have a special focus around AI. If you work in machine learning and AI, you probably know scikit-learn, and we are the people behind scikit-learn. I personally am a good friend of the team that developed scikit-learn. But not only that, INRIA has a lot of other open source software on, for example, Riot is a Internet of Things operating system, SOFA, Faro, OCaml was, if I remember correctly, the language was put forward by INRIA. And if we go back into the past, we are talking right now because INRIA invented in the 70s the packet switching protocol that is the core of the TCP/IP protocol that is the internet as we know it. But well, on AI, we just to give you a rough estimate, the people in INRIA are organized in in groups that are called project teams. There are like 200 project teams, more or less. They, let's say, are created and stop existing dynamically. So it's very hard to have a precise figure at any time, but around 160 of these 200 project teams work on AI in different ways. Some of them are, let's say, developing core results, doing basic science, and many others right now, because AI and machine learning in particular are becoming a sort of commodity technology that is available to many people. And as a recognition of that, we in France, we created and now coordinate the French program for AI for Humanity. I am really proud because my former boss in India was in charge of writing this. And so if you have any questions, I'm willing to answer them. But we have this, let's say, this particular strength, but not only. I want to emphasize, because as I am a machine learning person, it appears that we only do machine learning, but actually we work in a lot of things. So we have been in Chile, as I told you, for 10 years now, almost, and in October it will be 10 years. And this is our building in, let's say, in the area of Santiago, in Las Condes. We have a floor here because even though we are a center of Inria, we are way smaller than any other center of Inria in France. In France, we have our own buildings and all of that, but we are here. So please, if you, by any chance, get to Chile, do not hesitate to visit us. And by the way, I am in one of these windows, and you see outside the view. And the vision of the center, and this is something that I really like of Inria in general, and Inria in Chile in particular, is that Inria was born with a mission of connecting, let's say, science to industry, and putting this as like a organizational approach. No, we are not only focused or have the mission of conducting science, but also to answering the needs of the society. No, and this might be empty words, but for example, Inria led all the, let's say, computer science related efforts for fighting COVID in France, and we try to do also the same here in Chile. If you go to France, there is an app that you install to do contact tracing and all of that. Inria was in charge of developing the science to make a secure protocol to ensure that privacy is preserved and all of that. And so we have this connection between basic science and applied science that is actually really interesting. And I call this frequently that we have the two legs. No, we can make a step forward because we try to be, I think we are, but on the state of the art of what we do, but also by being connected to practice, this makes you move forward on your understanding, because practice imposes on you restrictions or let's say conditions that you cannot escape from. No, I always make this joke because my father was a physicist, and so I feel that I am clear to that. But it's not like when physicists prove something for spherical cuts in vacuum. No, when you are let's say when you are facing real world challenges, then you are you are challenged in a very different way. No, so it doesn't mean that we only apply science. It is not like that. Different things have different levels of, let's say, proximity to a final application, but we are expected to do that in this way. And there are many, we can spend hours talking about how Inria has organized this, because it's really interesting. I don't have the time, but just wanted to say that we have this mission. So getting into the topic of this particular talk, it is around AI and climate, no? And there are two distinctive scenarios, and actually it's a big contradiction at some point, or somewhat contradiction. On one hand, it is pretty evident, I have to say, that almost everything that we need to do to understand climate change and mitigate climate change implies do AI and machine learning in general at some point. And it is because first, we need to understand data, because one of the things that climate change is doing is that these implicit models that we have, imagine, I don't know, an agriculture that have been harvesting the same plot of land for generations, all of a sudden this knowledge is rendered useless because the weather patterns are changing. So this accumulated knowledge that we have on many things is becoming useless very fast because the conditions are changing faster than we are able to, let's say, update this knowledge. So, and then if we try to, for example, operate an environmentally friendly process, whichever process it is, by definition, the technologies that, in general, the technologies that we have are not so efficient. So we need to make this optimal, and you need AI to make that thing optimal. No? So it is a very clear understanding. And by the way, if you go, there is I forgot the name right now, but a very good site and project called Machine Learning for Tackling Climate Change, or something like that, by Priya, and I forgot the name of the other. Please say, put a beep in this part of the conversation. But they have, for example, a very good review of the different activities related on how you apply AI to one way or another mitigate climate change. And in the other side, there is a recent awareness of the impact of AI and machine learning in particular itself on the environment, because you are doing machine learning and probably doing deep learning, because I don't know, it's 90% of people are into that. So it requires a lot of resources. The awareness on this is growing because we are making bigger and bigger models that are more expensive to train. We have here in India and Chile, we have another project related to this side of the equation, no, on how to mitigate the environmental and impact of AI. And it's not only environmental, it's also about access and availability of this technology to a lot of people, because I don't know, more or less trying to remember out of my head, I think that training BERT, the language model, the electricity bill was like $3 million, no? So not everyone, so this implicitly is a divide. First, they consume a lot of energy, but then also not everybody has all these resources. It's true that, and I am really proud to belong into this community, that even companies share this and is made available to a lot of people, but this is a tendency that eventually will disappear. And we already see, for example, OpenAI that started to be openai.org and migrated to be openai.com and selling whatever they are doing. At the beginning, I remember that the mission was to use AI for the benefit of humanity, and I think that it's now for the benefit of somebody's bank account. I mean, I am not again making money. The only thing is that it is understandable because it is also really, really expensive. And we have been working in this other area. I am focusing right now during this talk in the left side of the equation here. And just to mention, for us, it's a big priority to work on this. For Inria in general, Inria, I think it was 2019, was selected as a year for the environment in Inria. So a lot of teams worked around these topics. We have been working for example, the topic I am going to talk today on OceanIA, but also on solar energy generation, on autonomous sailboats for environmental monitoring, offshore marine-based energy generation, either using wind or using tidal energy, smart agriculture, tsunamis modeling, that for Chile is a very important topic, and all of that. So we have an important leg here in Chile related to this area. We also work, by the way, a lot. I don't have the time to explain, but we work a lot on astronomy related applications. We also work in mining industry, because in Chile has an important impact, and some other topics. No, but again, I am trying to restrain myself to the main topic of the conversation today, that is this project we have started a while ago. And I decided to take this road, not just to tell you about our experiences, and also maybe motivate you to get interested in this area, in these topics, because first, hey, we need to save the planet, no? And then also being a computer scientist or applied mathematician, or let's say non-biology related scientist, is also a very interesting problem that poses a lot of challenges to our own science, no? So that's why it's so interesting. Well, the first thing, and probably I mean, this is like common knowledge at this point, but it is a well understood fact that the ocean is the main regulator for climate change. So our main protection against climate change is the activity of the ocean. A lot of people, of course, talk about the Amazon forest and all of that. Actually, the first source of carbon capture, as they call it, the fact that you turn CO2 into another thing, probably carbonates and eventually rocks and all of that, is because of thanks to the ocean and algae in particular, no? So this is a more or less well understood process in general terms, no? But then we are in a situation, we are in a situation where climate change itself is changing the ocean and destroying this protective capacity of the ocean. So it is like our main defense is being corroded by the thing it's supposed to fight and losing its effectiveness against it. So it's a problem of exponentially worsening problem, no? And we need to understand and answer a couple of questions to try to see how to protect the ocean, essentially, to help the ocean keep protecting us from climate change. And of course, once you are into that, also it's very interesting, because in order to answer this big question, you need to answer a lot of intermediate, smaller questions. So my talk, what I wanted to do, instead of going into, I can avoid going deeper into the machine learning aspects of this, but try to motivate you, because actually there are a lot of interesting problems that we can approach and where we can make a difference. And I will be talking about this during my conversation. So essentially, this is, there is not, as a computer scientist, there is not a better way to explain things than with a Venn diagram. And half a joke saying that, okay, we have all this inspiration on nature, like neural networks and evolutionary computing and all of that. So it's time to return the favor, no, to nature, and give nature a hand using AI and machine learning. And in particular, we need to get a better understanding on how the ocean help us mitigate climate change, no? Biologists and oceanographers have a decent understanding, but we can progress on that. And then what should be protected in the ocean? So at least the biggest capacity of this remains protected, no? And this is very important because, of course, we could all, as humanity, stop breathing and die, and this will protect the planet. But we need to find, we need to offer a viable solution to the issue, no? So how can we, for example, have some results that we can go to governments or communities and say, okay, if you stop doing this in particular, this thing will help the environment and the ocean and all of this in this given amount. So it's a big question that, of course, needs to be divided into smaller questions to try to conduct this research. And there is doing this, by the way, yes, writing the project proposal for us was really interesting. Doing this, we started interacting with, let's say, domain experts for us. So biologists and oceanographers and all of this. And it's really interesting because, as in many other areas of science, they are slowly becoming machine learning people, in the sense that they are starting to use knowledge or database methods to try to understand their problems and all of that. So on one hand, we can come and talk to them and show them that actually we have really recent tools that are way more powerful than the ones they are used to use, because, I mean, they are not computer scientists, so it's okay. They are doing their best. So we can try to, let's say, create this middle ground thesaurus where we explain the things that we can do, and then they can pose new questions that before they thought that they could not pose. For example, how do you discover automatically different ecosystems by taking samples? No, for them this was like something magical, and for us is actually you can see a really fast way of trying to do some sort of unsupervised learning and all of that to solve the problem. But well, there is like this upper link that say, okay, we have some advanced knowledge of the problems you are trying to solve. We can either help you solve the ones you already identified, but we also can come with new tools that actually can be applied to new problems. And then in return, actually, the problems that they have are not so trivial to solve. When you get to talk to them, they have to do a lot with what are the current interest topics for AI and machine learning. For example, they have a lot of small data problems, a lot of graph-based problems that need to be solved. Then they need to, they require a lot of causality, because it is not enough to have a predictor. They need to understand what is happening. Because, by the way, you need to go from describing a phenomenon to model this phenomenon, but also simulate scenarios. So to simulate the scenarios, you need to understand not only the process you are able to observe, but also other situations. So it's a very interesting and challenging domain. That is why for Inria, that we are a computer science institute again, for us, what's really interesting to get into this, because we thought that we can help, but also, we can do a better computer science by working on this. So there are different aspects, as you can imagine, and different people involved. And this kind of project in particular is what we call an Inria challenge. Inria has different ways of, let's say, supporting research. First, the teams receive let's say, base funding for operating. But then there are these Inria challenges. I think that right now we have more or less 10, just a number out of my head, that this Inria challenge is a kind of project that is executed in 4 years. We started this July, to give you an idea. And it's meant to make different teams of Inria cooperate. So, and as a new addition to this, we have also a lot of teams from outside Inria, in particular because here in Chile, we are, let's say, universities are part of Inria Chile, and we are part of universities. So we have a very strong collaboration with the Universidad de Chile, in particular with the Center of Mathematical Modeling and the Catholic University of Chile. That, by the way, we have a very good, intense collaboration in the area with the marine biology department and all of that. And then we also established a very interesting and strategic collaboration with Terra Oceans, and I will go into it. It's a foundation that operates an oceanographic vessel, and therefore they have high quality data. Again, this is a multidisciplinary project, so sincerely, by the way, I just came up from a meeting where we were trying to organize the work for the year, and the best way to describe how to, let's say, coordinate the project is herding cats, no? Because there are people really different from biologists, marine biologists, and all of this, to mathematicians that work on modeling and partial differential equations and all of that. So there is a very big and open catalog of different people. So it's I have to say, really interesting and really intense, no? By the way, this is the team, the coordinating team that we have right now. This is the photos that I had. This is me, and Mark, Michelle, and the rest of the guys of the team. We, as I said, we started a while ago. And then what is Terra? Terra is this foundation that operates this oceanographic vessel, and they have been running missions, sampling missions around the world for, I think, more or less the last 10 years. And these are the different missions that they have been executing. They have some interesting characteristics. First, of course, they try to understand the global ocean, no? For example, there is a very interesting mission where they remain frozen for, I think, 2 or 3 years in the Arctic to try to sample the ice and the water under the ice, etc. And we started to talk to them because we saw that they have first a high quality methodology for sampling and obtaining this information. This is not the only vessel that does this. The only thing is that as Terra is a relatively cheap boat, they are able to do something that they call gradients, that is essentially going on a mission where they do exhaustive sampling of the ocean, no? By the way, they do it by sampling the water. They are focused on taking samples of water, and at different depths, at any given point, they sample water at 3 different depths. And then, for me, this is really interesting. They are able to sift and separate the water, let's say the organisms in the water by size. So they have a filter for bacteria, another filter for viruses, and all of this. And then they go and sample the DNA in these samples of water. So you have this data already available. By the way, is publicly available. I think that the most recent one is still on the embargo of the recent mission, but all of this data is available. That for us was really important. And for us, it was also really interesting to see that there was already a community of people working around this data, no? And I have to say, personally, for me, it was a very nice discovery, because when you go and read the papers, I remember, and I think it was in this science number that was dedicated to Terra data, you can find situations where they say, okay, for doing this, we applied scikit-learn with linear regression, default parameters, and these are the results. So actually, this is a very good news, because they have done a lot of work to understand the problem, and now we can come in a positively but still opportunistic mood and help them say, okay, you have a regression problem, you know, there are better methods to be applied here. So we have been, we have a very good relation with Terra and the Terra researchers. There is a big community of people around this. And we propose a project that first try to address the challenges related to data access, because it's true the data is available, but it's really hard to get. Data is made available in a fraction way, so it's very hard to access a single source has of the data, and is expressed in weird or hard to process formats and all of that. And then by interacting with the scientists, the biological scientists, we identify a set of areas where we wanted to work. First, on, let's say, basic ML. Again, remember, Inria is a machine learning, computer science institute, so we are working in machine learning, but also identifying how we were going to apply. And this is, I'm going to briefly describe some of this to give you an idea of the interesting nature of this. No? For example, this is the data from the most recent mission from Terra. Terra is currently executing a mission in the South Pacific and South Atlantic. If I remember correctly, they are currently in Antarctica. And this is a good idea of what they call a gradient. I generated this for you today using the data we have, because they stop and do this sampling of the populations in this area. But if you are a computer scientist, the first thing is that you say, okay, in the Atlantic, there is actually very few data. It's like, I don't know, if you combine all the measurements they did, it's like 200. So it's like having a table where you have only 200 rows, but then a lot of columns, because something that they do is that they split the sample of water into different sizes of organisms, and then they go and sequence the DNA. And this is like sequencing the DNA of a soup, that as a result, you have chicken DNA, noodle DNA, onion DNA, no? And you just have these sequences back. It's true that there are methods for trying to say, okay, this DNA looks like a bird, so it's probably a chicken, no? And this is like some grass, so it's probably noodle, no? But it is a challenging problem, because there is a lot of unsupervised, or let's say untagged data that is available. But then there is not so much data that if you're a biologist, you would say, oh, yes, there is a lot of data, but actually no, there is very few data for applying classical computer science. And that's why this kind of problem is so interesting, no? Then they are really interested in, and this is a topic we have started to work with them, no? Is to understand the graphs, the networks, as they call it, of different organisms living together. Because if you want to, for example, protect the algae that are able to capture the largest amount of CO2, you need to understand who benefits from this, what are the relationships, and all of that. And that is why we have first a researcher full-time working on this, but a very big interest on trying to be able to operate on graphs and temporal graphs and all of that. Then, as you can imagine, there is a big effort related to these new kinds of learning. For example, active learning, few-shot learning, multitask learning, and all of this, because most of the data that we have is not labeled, no? And I have commented you already about the DNA, but another thing that Terra does is that they have a microscope with a camera, and they take photos of plankton as moving through the lens, no? So they have been creating, by the way, Terra is not the only boat that does it, but if you go to this site, Ecotaxa, you can see different data sets of this kind. This is publicly available data, and it's available, but not hard to, but rather hard to use, I have to say. Not trivial to use, but it's really interesting because a lot of the problems that we can want to solve in other domains are already present and readily accessible to us. And that's why I keep saying that we have this duality, that the problem is really important, but also it's a very good opportunity for us to work on, let's say, blue oceans, using this, as we are talking about the ocean, in a blue ocean when you don't have sharks competing for improving the F1 score on Sci-Fi 100, no? We can actually produce important results, but also meaningful results. No? So for example, we are working here to try to come up with an active learning tool so the labeling of data is done in an intelligent way, how to try to reuse knowledge, no? And then a lot of interesting questions arise because we need to understand, for example, how different populations change in different areas of the ocean and all of that. So it's essentially it's a lot of computer vision problems related to this. And for me, it's also really interesting. And by the way, I am just saying in the spirit of my talk, there is a very good opportunity for us because bioinformaticians and all of that, they know how to handle DNA information and sequences and all of that. But this is an area that for them is not really well explored. For example, something that we are working with them is that they need to have not only a classifier for plankton, but they want to be able to detect new species, no? And this is not trivial because, again, in this case, we do have a lot of data, no? But very few amounts of data are like trustworthy labeled, no? So we are working on this, but again, they are not interested, or having a classifier is important, but what is actually important is to have a research tool in the sense that, okay, this bug is a new bug that you are seeing, and it's new because this part here is different from what it should be expected. For example, you are seeing a fish with a different kind of fin, I mean, microscopic fish, or this bacteria has a different shape and all of that. So this is really interesting. And by the way, we are working on that in AI everywhere. So we can bring a lot of existing knowledge into this. And I wanted to draw your attention because I think there is a very good opportunity for doing it. And then we have another problem of the ocean is that it's really big. So it's like there are a lot of layers of let's say, sizes of grid that we can operate. And one of the problems is also that the ocean is in permanent movement and change, no? So we need to understand how we integrate these models that we have, for example, how particles are transported in the ocean, how different parts of the ocean impact another, etc., and see how they can be combined with database evidence, no? And here, by the way, I picked into the other talks you have been having, and we have stumbled upon, I have to say sincerely, for me, it was a relatively recent discovery, this idea of physics-informed neural networks. And we are working a lot, both, again, from a basic science problem, because once you get into this, I think that being a computer scientist or a machine learning scientist, actually, some questions arise. For example, I really don't like this thing that you're making a single loss by combining two terms that actually have a very different nature numerically. And so, for example, we have a mathematician working with us here, Hugo Carrillo. Taco the Wolf is working on the machine learning aspects of this. And I know, because you have been having talks around this, it's really interesting because I think that right now it is becoming a really hot topic, and we are first again trying to make progress in the basic science and see how this implies a progress in understanding the particular problems that we need to solve. For example, the shallow water modeling and the influence of turbulent water and all of this. It's really interesting. Then going into the more applied aspect, applied in the sense of the project, there are really interesting problems where they want to identify the relation between an ecosystem and the function that the ecosystem performs. No? There are ecosystems that capture, and this is more or less what this little image here tries to say. Some ecosystems are producing CO2, or are producing oxygen, and capturing CO2, consuming nitrogen, and all of that. So it's really important to be able to identify how we can relate an ecosystem with a given function. And this is a very important question, because we need to be able to identify these highly important ecosystems so we can protect them. No? And it is, well, a lot of causality, causal inference, and all of that to try to establish this clearly. And in this direction, we are also working on trying to identify, in the sense of, identify on the map these ecosystems using remote sampling data. Because, okay, you cannot have infinite oceanographic vessels sailing around the world trying to understand what is happening in every corner of the ocean. But what we can do is, okay, based on the data we have, can we, for example, using satellite information, be able to tell which kinds of ecosystems are being observed on satellite? In principle, this might seem like a crazy idea, but it is not so crazy, because different ecosystems produce different shades of the color of the water, and that's related to the location and doing some time series prediction and all of that. We are working on trying to do this, and by the way, this is a preliminary result that we have. We have identified different types of ecosystems in the shores of Chile. By the way, well, we have a Chilean in the call, so I will not talk a lot about Chile, because I probably will make some mistake, but Chile is very interesting from a natural point of view, and the Chilean waters are really important because there is a big surge that goes up the coast of Chile. That is one of the most bioactive, bioproductive areas of the world. No? So it's very interesting and important to protect this thing. So, and what we are trying to do is, at some point, there are many papers, or some papers that are able, relying on satellite images, telling the characteristics of the water. For example, the levels of chlorophyll and salt, temperature, etc. But we wanted to go further and say, okay, we are observing a pixel of water. Can we tell what population do we have? What kind of ecosystem we have there? And in particular, hopefully be able to tell which particular species and all of that. So that's a big question. We are right now in the A to D situation, but working on that. And then, as I mentioned, there is a bunch of work being done on making data available. And we, let's say, in the spirit of Inria, decided to create an open source platform for accessing this ocean-related data in an homogeneous way. It is available online. I forgot to add the link on the GitHub of Inria Chile. It's still a very little project because we are, let's say, focused on implementing the stuff that we want to work on, that we need at any given point. But again, it's available, and slowly different people are starting to use it, and it has a friendly Python interface and all of that. And to finalize this, I want to express that these are not isolated word packages or something. Actually, they are meant, and that's why let's say coordinating the project is rather complicated, because we are focused on trying to, on one hand, make progress on basic science, basic AI and machine learning, and modeling and applied mathematics, but driving this through answering important domain questions. No? And this is a big challenge of the project. I wanted to share with you, as part of a work, we have written this, pretentiously, we have called this a white book. It's some like the description of what we are doing, and make this available online on the project website, just to give you a more detailed idea of the things that we are planning to do. And we plan to update this document at least every year with the updates and the results we are obtaining. So in some cases, they are going to be disseminated in computer science, machine learning, mathematical forums, or other cases in more biology-related forums, but this is the overall idea. So just to wrap up and leave some time for questions and comments, just wanted to highlight again that the ocean and climate change are deeply related. In particular, this role of carbon capture, the fact that algae are the main actors on capturing CO2 and turning it into a non-noxious element, and also, of course, regulating temperature and all of that. So this is really important. And on the other hand, the ocean is really not well understood. As you get into that, you realize that even though there are a lot of good efforts being done, and I am really proud that we are working with leading figures in this area, there is still a lot to be done here. And it's also a good way and a good justification to address many interesting and hot topics like explainability, biases, and all of that, that then can be extended and reused in other domains. No? And I wanted to get you motivated on this. I think that right now the timing is right. We have very good tools that we can adapt to these kind of problems. Data is available. If you want, in any other moment, I can point you to some data sources and all of that. We plan to, again, in this document we wrote, we are listing the ones we're using at the moment. You feel free to I invite you to jump into this. And of course, right now is even more important to work in all of this, because I mentioned earlier that we had 2019 for Inria was the year of the environment, and 2020, sorry, it was not 19, it was 18. And 19 and 2020 became the year of COVID, and we have been working around this. So actually, I think that a lot of the experiences that as computer scientists we have developed during these 2 years actually can be reused and applied into these other interesting problems. So thank you very much for your time. And if you have any questions, just fire them.
Thank you, Luis. That's very interesting. If you have any questions for Luis and what he presented today, just let me know here in the chat. You can raise your hand, or you can type it on the chat and I'll read them out loud for him. I can ask a question for now.
Awesome.
I saw that last year you guys hosted a ICLR workshop on this topic. What were like the main takes of that workshop? How was the experience? Was a lot of people interested in what you guys doing, or?
Well, thank you for the question. Actually, I had a very positive feeling from the workshop. By the way, between us, we tried to organize it again this year, but was rejected. So, I mean, we are not the only people working. There are probably other workshops related to environment and all of that. I do not doubt that it is a priority for iClear, but our experience was really interesting because we realized that there was a community of people trying to make AI and let's say biological applications meet. And for me, it was a big confirmation of that physics-informed neural networks are a really hot topic, because a lot of people were trying to look at the problem of physics-informed neural networks from different perspectives. And the way I have to explain this, or my opinion is, you know, this fable of the philosophers that hug, blind philosophers that hug an elephant, and each philosopher is hugging a different part of the elephant, so they have a different understanding of what an elephant is, no? And at some point, I think that physics-informed neural networks are the elephant right now, and each of us are trying to hug a different part of it, no? And for me, it was really interesting because, again, as it is, modeling in general imposes a lot of challenges on the theory. People were working either from applications on modeling, relying on images of the ocean and all of that. So I was really surprised. I was expecting first a more varied participation. Most of the papers that we got were applying pings one way or another, no? Maybe that's why it was, because we included modeling in the title of the workshop. So yes, that attracted that part of the community, but it also had machine learning, and they were not so many. So for me, the biggest outcome of the workshop was that.
Okay, yeah, that sounds very interesting. Rosella, I have a question. Go ahead.
If you don't mind, I will stop sharing, and so I can see you all.
Yeah, no worries.
You can stop sharing. So yeah, first of all, great, great the use of the elephant. I completely agree with you, and yeah, it really gives the idea of what is happening. So yeah, thank you a lot for the talk. Very interesting. I have actually lots of questions, but probably I will just try to summarize a bit. So just the title, Ocean AI or EA, is something really, touching my heart. I have done my PhD in Ocean with the Euro-Mediterranean Center of Climate Change. And we did assimilation. The software was called OceanVar, and it was more than 10 years ago. So AI was not so popular as a terminology. We just say data assimilation and stuff like that. And so to be honest, what I've seen in this presentation is something that I can say without any problem that is definitely the future. So it's very nice seeing that there is this huge community working on this. But my questions are more related to the project. So when is the project actually ending? And so what is the stage of the project, and how is working with the collaborations with other institutions? And yeah, mainly this, and then we can.
Okay, well, the project officially started on June 1st this year. Well, last year, sorry, we are in a new year.
Yeah.
And it will end on July 1st, 2025. It's a 4-year project, no? And it is meant to fund people in particular, no? So essentially hiring people to do parts of postdocs, PhD students, master students, engineers if we didn't need them. No, Inria is our own funding, so in that sense, it's nice because if I hope my boss is not looking later at this, but if I want to buy a Ferrari, I just need to go and convince the scientific director of Inria that the project needs a Ferrari. No, it's not that you need to write a big grand proposal to. Of course, we it's in that sense it's very nicely organized because we can adapt to the needs of a project as we discover what are the uncertainties. So this is a 4-year project. Just to give you an idea, it should be like 1 million euros, no? But again, for example, we have spent very little money because there is no traveling and a lot of other things are not happening, no? That was supposed to be part of the project. So, so we started 6 months ago. In practice, I have to say we started way before because we started writing the proposal. Then once you do it, you start to say, okay, we knew that the project was being accepted, only that it was in the process of being accepted. It is France, you know, Napoleonic bureaucracy takes a while to execute. So we started to work probably at early 2021, no? On, let's say, work, no? Actually, for example, the workshop that Cesar was mentioning was organized in May, no? And the project actually started on July, no? That's why we started to do this because we knew that we had been clear of the only thing that we need to refine who would be participating, which Inria teams and all of that. Then what we have organized, the way we have organized this is that we have for each line of work, each work package, one of these phases that I showed on a slide, one of the project coordinators is in charge of this package in particular, no? So for example, here from Inria in Chile, Nayat and I, we are handling the ones related to learning and graph-based neural network. Marcio Nauer and Michel Sivac from Inria Saclay are in charge of causality. No, I was posing it as a half joke before, but it is like herding cats. It's not simple at all, no? Because you have really different ways of even facing a problem. No? For a biologist, just seeing a plot is enough. No, maybe I'm not saying. By the way, I'm very positively surprised of the once you get into the details, but it's really hard to coordinate.
Yeah, but it's beautiful. It's a beautiful project, and we will be happy to share that with our network and disseminate your.
Awesome. No, and I wanted to. We also wanted to be an open project in the sense that if people want to work on this. It has a complete vocational thing, no? We are doing this because we want to, and we were lucky that the timing with Inria, the direction of Inria was right because it aligned really well with the priorities of the center. But again, we are not like we are trying to open the can of tuna. We are not collecting cans of tuna, no?
I see. Yeah, but I think this is the great approach that you can implement now.
Yes, thank you very much.
Yeah, actually, then I will leave. Sorry, Cesar, to you to continue with the questions. I just want to say that every year we have, talking about networking, every year we have workshop organized as part of the International Conference on Computational Science, ICCS, the top conference for computational science. So the workshop is on, let's say, data science and machine learning for dynamical systems. And this is the 4th year that we organize that. We have like quite big community now, also with usually attendees from the other operational centers, like other centers in France, but also the ECMWF, the CMCC, etc. So we are happy to share our call. So in case you are interested in submitting even just a one-page abstract and then attend to the meeting, we will meet this year. We'll be in London. So we are not really moving. Over the past 2 years, it has been online. So anyway.
Yes, let's see. Well, first, please keep us on the loop. For us, it would be, I think that a big part of this is working as a community, no?
Exactly.
And very frequently, I feel that a lot of people are, we say in Spanish, rediscovering warm water, in the sense that something that this is common in science. You know, machine learning is full of these examples that things were already published 50 years ago.
Yeah.
Different
but names.
It's interesting to have these exchanges. So please do. For us, it would be awesome. And we right now there are a lot of uncertainties because, and to make things worse, I don't want to, you know, Omicron and all of that. But
yeah, but the meeting, if there is, so probably it will be hybrid anyway. So
no, but for example, in our case in particular, both Nayat and myself, we do travel a lot to France because of work. So it would be a problem of letting us know with time, and we can organize how we do it. No,
actually, I can. So I will send you an email. I can send here in the chat the call that the call for. Probably the link is not working properly. So I think we can send you the call.
Okay, no, but yeah, I think that with the name I can Google it. Awesome.
Yeah.
Well, I can send you the email with the link.
Very good. Thank you very much for the opportunity.
No worries. Well, it's very interesting, and I really wanted to see what like researchers in Chile are doing as well, because I feel like I've been a bit detached from it. But yeah, it's good to have you in the network now.
Yes, and well, for I am not Chilean, but I once you get here, you start to realize all the opportunities that. And that is why Inria has a center here, no? So there are many interesting problems that, in order to understand them fully, you need to have some local people, no? So for the time being, I am here, but the intention is that we keep this link, and I mean, we can spend another hour talking about astronomy and all of that. That is another very interesting area. Domain of problems, no? But awesome.
Yeah. I think you're right. It's good. And also like these workshops, these seminars are kind of like turning around into, we try to keep them very broad, but in the last year has been very like focused on physics informed neural networks, mainly because like I invite people working in that area. But yeah, so I also let you invited for like other seminars that happen every Tuesday. So far we have speakers all the way until March, but we'll probably have speakers all the way until June, then take a break and then continue. So actually, initially it was in person, but with COVID, it gave us the chance for this to be international, and we had like really good speakers in the last 2 years. So thank you for being part of being one of them.
It's a pleasure.
And I think it's already like it's 5:07, so I think we can leave it up to here. Well, awesome. Thank you so much, Luis. Very good talk, and yeah, enjoy the summer.
I will try. I have
Okay.
a particular strong tongue today because I am enjoying the summer. Awesome.
Yeah.
Take
Okay.
care.
Okay. Bye-bye.
See you soon.
Thank you.
Bye.
Everyone.
Bye.